there are many different ways of implementing AI on RISC-V, and it's so exciting.
In this episode of Embedded Insiders, Ken sits down with Andrea Gallo, CEO of RISC-V International, to discuss the company's upcoming RISC-V Summit in Bologna from June 8th to the 11th. They also recap this year's Embedded World exhibition and conference, highlighting AI at the edge and industrial robotics as the top trends at the show. Next, Rich and Vin are back with another Dev Talk discussing the different definitions of AI and recent news about ARM becoming a silicon provider. But first, Ken and I are discussing upcoming travel to NI Connect in Fort Worth and Computex in Taipei. Hello, everyone, and welcome back to the Embedded Insiders podcast. I am Assistant Managing Editor Tiara Oliver, joined as always with our Editor-in-Chief, Ken Briota.
Hello, Tiara. How are you today?
I'm good. How are you?
Fine. It's a lovely spring day, although the sky is a little overcast. We had a beautiful sunny weekend, and now the sky is overcast because I assume we're going to get some rain. But yeah, I'm feeling good. The week is rolling like gangbusters. This whole year is rolling like gangbusters. It's so fast.
Agreed. Yeah. I can't believe we're already almost halfway through the year, and we've done a lot already, and we've got some more things coming up. So
yeah,
I think we've stayed busy. So that's kind of why the year's moving along.
Yeah, it's a little bit bonkers. We've been doing like a lot of field reporting this year and more to come for sure. Yeah. I know you've got one coming right up. Is that next week, right? At the time of recording. So like in terms of posting, will it also be next week?
I know it might be next Friday, depending on when I get back. I know. So I'm going to NI Connect in Fort Worth, Texas. And I know last year there was like a bit of a storm, so I had some delayed flights getting back, but hopefully don't have to deal with that this year. But yeah, last year was my first time at NI Connect at the event, and I thought it was pretty great, and I'm excited to go back this year. I feel like their event, I mean, I haven't been to a ton of different events hosted by companies, but theirs seems like a little different. I like how their keynotes are very much customer focused. Like they have their own customers on stage, talking about what the company is doing for their company, how they're using NI and Emerson products in their products. Yeah.
That's awesome. Yeah, that kind of vendor show can be really a great way to get your head around one particular big company and what they're focusing on. So I'm really looking forward to hearing your insights as to what comes out of that. We're going to have to talk about it, maybe even here on the podcast. But because the idea of those shows is really, really cool. And I Connect has been a good show forever. So that's that's exciting. I'm a couple of weeks away from my next trip, which I'm very excited. But the first week of June, I'm going to be back in Taiwan for Computex, which, if folks don't know about it, is such a cool show for the embedded industry. It's put together by Taitra, which is sort of like a economic development commission or like business development ministry in Taiwan that helps to support the local Taiwanese businesses. And that's what the show is for, is to sort of let them showcase what they're building and what they're doing. And as everyone knows, Taiwan is such a hub of semiconductor and compute and all that stuff that there's so many cool things. I know I'm going to be meeting with some of the major players, Advantech, AD-Link, some of these companies that we just always write about. And It should be really, really cool. I know we're going to be recording a bunch of video and things to give people a little behind the scenes look at what's happening on in case you missed it. And I may even have an opportunity to record a couple of podcast segments that you folks will get to listen to. But that's always a little bit tricky because we don't have a sort of studio space, so recording on the fly in a busy exhibit hall, as you might imagine, is tough. So we'll see what we can do.
Yeah. No, sounds great. Like I know you've been to that event a few times, so I'm
This is
expecting
just
them.
my second one, actually.
Oh,
This will
okay.
just be my second. We're both having a second year.
Yeah.
This will just be my second time at Computex. And I'm really looking forward to it. Aside from the fact that it's a great show and it's so good to get to meet with folks who, because we're on opposite sides of the world functionally,
Mhm.
I don't get to meet with them all the time. Um, Taiwan itself is such a wonderful place. It's so cool. The food is incredible. Everything is beautiful. It's so nice. I'm really looking forward to returning to visit another night market
Ooh,
this time, and maybe even do a little bit more exploring of Taipei City. So
yeah.
should be fun.
That sounds great. Yeah. I think, everyone out there listening, just as we always say, of course, we're drilling it in. Keep an eye out on our site, on our YouTube. We've got a lot of things going on this year. It seems like year by year, we're kind of just building up the momentum. Weekly podcasts, video podcasts, more traveling, and more
Yeah.
coverage of different events. So just stay tuned, is all we can say.
Yeah, we're gonna have to pretty soon strong arm our colleague Chad into coming into one of these to talk about, because Chad's going out and covering some events in the next couple of weeks as well,
Yeah.
and we're gonna have to have him on here to tell us about it.
Exactly. I know we talk about some of our own stories and travels, but yes, we definitely have to bring him on because yeah, people aren't realizing that not only are we doing stuff, but Chad and even Rich are doing stuff, so
Oh yeah.
the coverage is out there.
Yeah, absolutely. While you're listening, make sure that you're looking ahead at the events that we have coming up. Obviously, Embedded World North America is coming up in September. We've got Electronica in November, and we're going to be doing podcasting. We're going to be doing our Dev Zone. We're going to be doing at Electronica a whole speaking slot. We're moderating, I think, 2 tracks in their conference there. So if you want to take part in any of those shows and maybe have a meeting with myself or Rich or whatever members of our team end up going to these shows, make sure that you send us a line. We've got lots of ways to contact us through embeddedcomputing.com and everywhere else. But drop us a line if you'd like to get involved. We've got lots of ways for you to partner up with us on these upcoming shows.
Now, here's Andrea Gallo, CEO of RISC-V International.
Hello, engineers, developers, and friends in the embedded computing space. Welcome to another segment here on Embedded Insiders. I am, as always, Ken Briota, Editor-in-Chief of Embedded Computing Design, and I am so happy to be here with Andrea Gallo of RISC-V International. Andrea, great to chat with you again. Welcome.
Hi, Ken. Thank you. Exciting to be with you again.
Always a pleasure. We only basically got to wave at each other in the hallway back at Embedded World, so I'm glad we were able to find time to sit down. And I want to start sort of with you and with RISC-V International. I know Embedded World is a big show, and you've got your summit coming up pretty soon, isn't that right? What's going on?
Yeah, it's quite busy days at RISC-V. And we also met at CES, and that was another packed event.
That was.
Remember that one? So yeah,
it's so long ago.
Very busy days. And we also released our annual report just a couple of months ago, a beefy 50 pages report on everything that we accomplished in 2025. So I think there's a lot of traction, a lot of things going on, and Embedded World was a very, very busy event for us. I had close to 30 meetings back to back over 2.5 days. We had 9 sponsors on our members showcasing all their products. And we had a theater with a continuous roll of talks. We're also part of the larger theater in Hall 5, which was also quite busy. We had 3 panels. And
I got to watch a little bit of one of those panels for a minute as I was walking through. I saw that it was going on, and I was like, all right, I'm going to take 5 minutes and actually pay attention.
Yeah, and AI at the edge and industrial robotics was everywhere in the embedded world. I think that was really the big theme. And
for sure.
Right?
Yeah, absolutely. And I think that the other sort of big theme that I saw, especially with reference to AI and edge AI, was sort of the use cases and practical applications side. I was seeing a lot of sort of scale for sale products rather than just prototypes and proofs of concept and things like that. Empty boxes designed to look nice. I saw a real product out there. And a lot of it was RISC-V. A lot of it was.
And we also had quite nice products on show in our developer zone. We had a pretty expensive Amazfit smartwatch based on RISC-V.
I saw that.
I can tell you that we had to keep a close eye on it and lock it down at the end of the day.
I believe it. Everybody wants to, try it on for a little while.
Yes. 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 I think the other thing was also automotive.
Oh, yeah. Right? Yeah. I mean, automotive's been hot for RISC-V for a little while now, but that doesn't seem to be slowing down. It seems like you're just having more and more adoption.
Yeah, and our automotive SIG is quite busy.
Oh, that's great.
Yeah, we started it end of 2024. We got the official elections last year. It's now chaired by representatives from Infineon and Tenstorrent. And then there are many other members, Sci5, Codasib, Nuclei, Kintauris, all involved. And they are all ISO 26262 certified. So it's real stuff. And it's production. Everything is getting really production ready. That's
absolutely true. And I mean, gas prices being what they are, EVs are getting more and more attractive again, and that's going to be more and more opportunity for RISC-V. And as the cars get smarter and the processing needs to be faster and more modular and more efficient, RISC-V's got a home base there, huh?
What we love is that as RISC-V as a single ISA can scale from the ECU, the electronic control unit, to the zonal controllers, the AI accelerators, and the central compute. One single ISA replacing microcontrollers, app processors, GPUs, and NPUs, everything based on the same ISA, the same programming model. Yeah. That's what really, really excites us.
So at the highest levels, what are some of the goals for this year for RISC-V International and for you? I mean, what are you guys trying to put out there this year?
On the technical side, we're making very good progress on the upcoming matrix extensions. We have a significant number of extensions on security in the second half of the year. We are going to add white papers and continuing on the software enablement. So building on the RVA 23 that we announced, we released, actually, we ratified in October 24. Now you see already from last summit, all the companies that are announcing or taping out their designs based on RVA 23, and you have all the software ecosystem that is enabling it. So Canonical was very vocal that Ubuntu supports RVA 23, and Red Hat previewed or announced their developer preview for RHEL, for RISC-V. And in Yocto, with our own efforts in Yocto together with RISC, the RISC-V software ecosystem, together investing in Yocto. Today, RISC-V is on par with the other ISAs in Yocto. So the Yocto release is starting from 5.3. They officially support RISC-V, which is awesome. And it goes back to embedded world and edge AI, because Yocto is a tool to build your embedded Linux. But at the same time, it also provides a long-term supported file system, and it also brings a high level of kernel testing, all based upstream. So for us, the efforts in Yocto are a building block that enables all the long tail of the embedded developers. And then there's AI. We always have fun in reminding people that the V in RISC-V is the Roman cardinal number for fifth, as the fifth generation of RISC from UC Berkeley, and it also V as vectors, so AI native, because vectors are the key operations and the key extensions to accelerate AI, and so Yocto, embedded Linux, edge AI, they all go together in this huge market.
Absolutely. I mean, the Yocto native is huge news. That's a big deal. I mean, you can't walk through a tech show without tripping over 25 Yocto applications these days. So that's a big deal.
And it's not just in the traditional embedded Linux, but it's also used in the Linux Foundation AGL. It's also used as a baseline in, the VDA, the German VDA S core. It's used in set-top boxes. So it's a fundamental building block, and so it's absolutely part of our focus for to help the developers.
Yeah, absolutely. I mean, we should definitely touch on the AI side too. I mean, I know you're working in smartwatches and wearables and that kind of side, tons in as you were just talking about, tons on the vector side. What is the next AI frontier for RISC-V? Are we talking about getting involved in what?
So the first point is that RISC-V can be used as the controller of AI accelerators. It can be used as the compute unit of an accelerator itself. It can be used as the host processor, and it can also integrate everything in one single RISC-V instance. Thanks to the vector extensions, thanks to the matrix extensions that we are finalizing, it means that you can run your AI algorithms on a RISC-V processor, and you can also do execute the algorithm themselves without offloading to an external unit. So having everything inside the same unit means that you don't move data across. You don't do mem copies or DMA, which means latency, because you need to move data around, so it takes time, and it consumes power. Whenever you transfer data, you move data, that is power consumption. So running the processing on the same unit as the framework, it means that you are saving time, you are saving power consumption, you are reducing latency, so you have better performance. And then there are many different ways of using RISC-V in AI, which are already out there. If you look at, you can have examples of the products announced publicly by Tenstorrent or Inspire Semi or Semidynamics. You have this huge number of cores with specific processing units inside, so hundreds or thousands of cores altogether. That's a very powerful accelerator chip.
Yeah.
But then you can have other implementations where you have the host processor, big, very powerful RVA23 compliant processor. So there are many different ways of implementing AI on RISC-V, and it's so exciting.
It really is. Let's talk about the summit coming up. I mean, what can folks expect who are going to be, attending? Are they going to be looking at some new announcements and some new applications and tech, or what are we looking at? What's the scoop, Andrea? Tell me the secrets.
We are announcing the keynotes, I would say one per week. So the one that we just announced is that Greg Crow-Hartman himself, he will be with us at Summit, and he will give a keynote. He is the first keynote speaker that we have announced.
Incredible. That's great. What a get. Good job.
Yes. Yeah. And
you want to give me any that you haven't announced yet? That'd be awesome.
I don't know.
No, probably not.
One thing that I can share is that we will run the first developer workshop for RISC-V in Europe. We had the first one in the US last October.
Right.
And now we're running the first developer workshop in Europe.
That's so exciting.
It's a very big thing for us. We have been, over the years, we have been growing our catalog of free online courses. My favorite one, I will always repeat this, my favorite one is design your RISC-V CPU core. And I think that even software engineers, every software engineer should take that course. You will appreciate the elegance of the RISC-V ISA from that course. And at the summit, at the developer workshop, we will have specific hands-on sessions. First of all, we will have the completion of the community challenge that is going on now. There are more than 700 developers who are currently registered and are participating in this community challenge that is designing a high-performance pipeline RISC-V CPU together with Professor Tobias Schippel from the University in Graz in Austria. And they will have their final session at Summit. And we will have a hardware track and a software track, porting software to RISC-V, optimizing for RISC-V vectors, running trusted execution environment on RISC-V, advanced debugging, porting and testing Zephyr on RISC-V, running AI at the edge on RISC-V. These will all be hands-on sessions. Yeah. It will be 2 rooms from 8:30 a.m. to 6 p.m.
You'll have people asking, why isn't there another session? Because we'll stay here till 9, I promise.
And because it's only $30 or €30.
Oh, that's incredible. And people can register for that alongside registering for the summit?
It's separate from Summit. So people can either register for both or for either one. We want to make this developer workshop available to as many as possible and as low cost as possible. That really, it's a lot of effort from all the speakers. That's really what is exciting me so much.
That's very cool. Remind me, where is the summit?
The summit is in Bologna, in Italy.
Oh no, oh man.
It's not my fault.
Yeah, are you just half-hour commute for you? Just
yeah, kind of. So I tried in all possible ways to have it elsewhere so that people would not say that I was the one who took the decision. I swear the local committee decided.
That's all right, Andrea. The wine and cheese at Andrea's house every night after the show, and well, that's about, unfortunately, all the time we've got in today's segment. It's always a pleasure to chat with you, though. Thank you for giving me such a quick download on what you guys are up to right now.
Thank you so much, Ken. Thanks for having us. It's always a pleasure.
No, I really appreciate it. And we're going to have to do this again real soon. And I'm looking forward to hearing everything that comes out of the summit. That's going to be really cool.
Yeah, we should have another chat after summit for sure. Yes.
Absolutely. Thank you so much, Andrea. Have a great one. And everybody out there listening, don't forget to subscribe and share this podcast around. And if you happen to be anywhere near Bologna, get yourself registered for the summit and those workshops because they sound really cool.
Now, here's Dev Talk with Rich and Vin.
Good afternoon. Welcome to another edition of Dev Talk with Rich and Vin. I'm Rich Nass with Embedded Computing Design. The guy in the funky looking tie there with the, I don't know, does that match? Would my wife allow you to wear that outfit?
I don't know. I don't know if she would or not. I have subscribed for a long time with two fancies in a plane. So you can't have three fancies, but you could do two fancies in a plane. So tie and shirt and plain jacket, or plain pants, or tie and jacket and plain shirt. So two fancies in a plane has been my sort of signature look. And this actually came to me from a private shopper at Nordstrom's years ago. I had a private shopper at Nordstrom's. So there you go.
I disagree, but that's neither here nor there because I have never been accused of being a fashionite.
No.
That is certainly for sure. Okay, so Vin D'Agostino, the other guy on the other end. How are you doing, Vin?
Two fancies in a plane. I'm doing great.
Very good. But does the plane mean airplane?
Sometimes I've been traveling a lot. For those who are listening, where I'm actually doing this remotely at a client's office because we've been trying to do this and I've been traveling so much.
One of these podcasts that I want to do later on is, I actually wrote this down and it's a really good topic. Is there life after 60 for an engineer who's looking for a job? But don't comment on that because nope. I know you can talk about that for quite some time, but we want to talk about something else today. But that's a good one.
That is a good one. Let's put that on the list. Absolutely.
Okay. So what I want to talk to you about today, I actually had this discussion with a guy from Infineon and on the Embedded Executive podcast, which just came out this week or last week. But I'd certainly like to hear your take on this as well. What is the real definition of artificial intelligence? And are we applying it properly to the products that are out in the market? And where I'm going with this, I guess, is it marketing spin? Or is it really artificial intelligence? And I know I have my opinion, but I'll let you talk first.
Well, I mean, let's talk about the marketing spin first, because that's the easy part to talk about before we talk about the technology. If you think about it, and you talk about life after 60, you and I are old enough to have lived through a bunch of these technological marvels. When I graduated from Stevens, it was when I started as a freshman, it was the first year they weren't teaching tubes, right? So things went from tubes to transistors, and everybody was selling things that were called solid state. And then after that, when MCUs and stuff became available to everyone who wanted to design with it pretty easily, everything was suddenly smart. And people were putting smart on the boxes of their products. And then when IoT came around, everything was connected. And now everything is AI. So for every one of these technologies, there is a marketing spin because people are looking for market share. And for those applications where you're just putting a label on a box, the definition is pretty thin and pretty flexible, right?
We'll stop there. Okay, what is a thin and flexible definition? What can you do? Name a product, whether it's a white good, whether it's a router, something else. What's passable?
I mean, let's talk about refrigerators, right? You could say that a refrigerator is AI if it's doing something like counting the number of times you open and close the door and how long it's open, and using that to predict where the temperature is going to go, and add more refrigeration when the door is closed before it senses that the temperature is dropped. Because if you think about the physical mass of a refrigerator, it's radiating heat or accepting cold, right? Even when the door is open, but just less. And so you won't necessarily see that right away. But if you know something other than what you're directly measuring, which is the temperature, you may be able to do something to affect it and therefore keep the temperature stability closer to normal. And you could call that artificial intelligence because you are using other information to not measuring temperature to control temperature. So how much of that you do?
In this first round of products, it's far simpler than that. It's just find me something that I can call AI so I can put it on the box.
Yeah, 100%. 100%.
Is there enough ice in the bin right now, or do I need to make more ice? And I think what you're referring to is real and actually will make a difference, but I don't see that sort of stuff happening yet.
Right, but I mean, it is real, and you could say it's artificial intelligence, and we'll talk about that in a minute. But there's so much more that you could do. You could be analyzing the air in the refrigerator and determining spoilage of foods. You can potentially monitor the air and figure out what foods are in what cavity and keep it at different temperatures. I saw an interesting.
But at what cost? Do you want to spend an extra $2,000 for a refrigerator that's going to save you 50 cents in energy a month?
Is it 50 cents in energy? Is it $2 or $3 in food? Or is it the fact that you thought you were going to be ready to make dinner tonight and you pulled something out and it spoiled and you didn't realize it, and now you're scrambling to make dinner? So some of it is cost, some of it's convenience.
Or that you can tell all your friends that you have an AI refrigerator.
Or you can tell all your friends that you have an AI refrigerator. Yes. I was listening to an interesting podcast on refrigeration, and people will be like, "You're listening to podcasts about refrigeration? You have no life." But it was very interesting.
He's really cool.
Yeah, it was very cool, actually. But it's actually something that's pretty rich history. And they talked about a whole bunch of foods and the slight difference in temperature that determines how long they stay fresh, right? Different vegetables, different fruits, different meats. And so, if you have the ability to detect that, now you are actually making some intelligent decisions about how you keep your food stored. And I think that is really what it's about, because it's not, for me, artificial intelligence, especially on a device, is really simple. You are using statistics and aggregated data and some analysis to be able to predict the value of something that you can't measure directly. If you can measure temperature directly, you measure it and you take action, turn on, turn off, whatever you're going to do. But let's say you have 6 sensors around a space and you need to triangulate the temperature in different parts of the space. Well, if you assume it's static, it's simple math, right? Very algorithmic. You take these things, you know the distances, you do some mathematics based on thermodynamics, and you're all set. But what if you're monitoring people walking around the room? What if you're monitoring doors getting opened and closed?
Oh, that's the key. Dynamic. You're monitoring dynamic things. Okay, I didn't see where you're going. Now I understand.
Yeah. So see, that's the thing. You are. It's funny. I went to a very well-known university years and years ago when I was at Renesas, and we were just starting to look at AI and stuff. And they are very famous for AI, and they rolled out the red carpet for me. It was a lovely day at the school. And at one point they had me meet this professor. She was working with municipalities on using AI to predict pothole size and when you should deploy trucks to fix the pothole. And I'm thinking I'm going to go in there and they've got cameras at every corner and they're monitoring cars and trucks in and out, and they assume the weight and they know the temperature and they know something about the soil underneath. And just from that information, they're determining whether a pothole exists on the street. That's not what they were doing. They were finding potholes and pointing cameras at them and supposedly using AI to determine when the circumference of the pothole was big enough to send a crew out. Well, I don't know why that's AI. I mean, that's just kind of crazy, right? I mean, that's a simple circle. A lot of potholes are round or they're rectangular because it's either a trough cut by by a tire, or it's a sinkhole in the middle. And so those equations have been known since Archimedes. So I'm not sure why that's artificial intelligence. So, and that was, a decade ago. So I'm sure they've gone well past that. And
so
I think
what is artificial intelligence today from a technology perspective? Looking at the MCUs that are out there that people are putting in these devices, what makes them AI MCUs?
Okay, AI MCUs is different than AI as a technology. An AI MCU would have an accelerator, for example.
I'm trying to stick to our audience.
Yeah, so if you have some hardware acceleration modular in the silicon that is helping you get AI done faster, you could call that an AI MCU. There are companies, and you and I have talked about this. Renesas owns Reality AI. They are an AI company doing embedded AI, and they are basically using the DSP extensions of the ARM instruction set and using DSP to analyze streaming data from sensors and applying AI techniques to that data to make some determinations.
Applying AI techniques, what does that mean? What are AI techniques?
Okay, so you are training a model on what it means to, okay, here's a good example. Those of us who are old enough to have done Carnot maps to reduce digital equations and digital circuits realize that you have things that are called don't cares, right? Where it doesn't matter whether it's a 0 or 1, it doesn't affect the output. And you do that to initially to minimize the, okay. So if you think about all the data you can take on a system, let's say you have an HVAC system and you've got maybe 120 things that you could measure, and you're looking for certain things. You're looking for low refrigerant. You're looking for, is the indoor air coil blocked? Is the outdoor air coil blocked? Is the fan blade outside no longer balanced because it got hit by a piece of hail and now it's spinning off center, right? These are all conditions that can happen. If you want to measure those directly, you're looking at flow sensors, you're looking at accelerometers, you're looking at pressure sensors. You are probably adding a couple $100 to the bill of materials plus all the wiring to get them all set up. That's a non-starter for certainly residential, if not some small commercial systems, right? That's a high percentage. But what if there's other data you could look at, the different phases of current going out to the motor to see if there is a change in imbalance? What if you could look at incoming and outgoing refrigerant temperatures to see if you're transferring the amount of heat that you expect to, and that'll tell you whether there's airflow, right? These are all things where you are measuring, you're predicting airflow, let's say, based on how much heat comes out of or cool comes out of a refrigerant through a coil that is well known. You need to train it. You need to say, this is what normally happens at this outside temperature, this inside temperature, blah, blah, blah. And you build this matrix and these patterns, and then you compare it. So you have maybe 120 things that you can measure in the system. You measure all of it and you look at it and say, well, these 4 conditions are the things that change when my trigger point, if you want to call it that, my condition that I'm trying to test for occurs. So now you've built up all this data. You've done your don't cares. I don't need to look at these 117 pieces of data. I only need to look at these 3. So the experimental part at the beginning is key to efficient AI. And now you're only looking at the things that really matter in concert with each other. And you're using those things to predict something that you're not measuring directly. You can now do that $200 worth of sensors, if you could work it out, for probably a bill of materials of under $5, right? That's a couple of thermocouples and maybe something measuring, I don't know, the vibration of something, the position of something.
I think you just spun it back to the refrigerator at that point.
Certainly this could happen in a refrigerator too. I mean,
yeah. I mean, to do predictive maintenance for something like that, to know when the fan is a little bit off kilter and that kind of thing, or okay.
Yeah, I mean, I'll share with you a really simple example that somebody gave me early on to talk about AI. He said, let's say you're in a car and what you have access to is speed and acceleration, right? And you make an XY axis. If you have a lot of acceleration and deceleration and low speed, you could probably predict that the car's in the city. If you have a lot of speed and not a lot of acceleration or deceleration, you could predict that it's on the highway. If you also, for example, knew the position of the steering wheel, you could determine whether it's in the city or in a parking lot, right? So these pieces of data, and now you're not measuring with a GPS where you are, but you are using other data to say, hey, this seems to me like they're moving on a highway, or this seems to me like they're moving in a city. I think that's a pretty illustrative example of how you can use secondary data to predict the thing that you want to predict. So, and that is something that will, what you want to do and how you want to do it will also help predict whether you're going to do it on the device, on the edge, you know, in your space, on the gateway, or on a little server on your LAN, where the response time would be a little less than on the device, but faster than in the cloud, or whether you're going to go out to the cloud. And it's how much horsepower do you need? How much data do you need to push? Imagine trying to look for frequencies of vibration with data in the cloud. You either have to take a sample and push the whole sample up, or you have wide bandwidth where you're sending all the samples up. That is costly on storage, it's costly on server, it's costly on bandwidth, right? But if you could do it locally on the device, you're saving all that. And then on top of that, think about the privacy of your data, right? That if you're doing it locally on your device, it never even leaves the device, let alone your LAN. Putting stuff in the cloud, you never really know where it's going to go. So these are all considerations in whether you're going to do it on the edge, on the device, or in the cloud. And all of that determines whether you're really doing AI or whether you're just relabeling something that you were doing kind of like AI, so you could put AI on the box. But
okay, let's shift gears completely, because I think we've talked about that one. Because we're not out of time, but I don't think we have a deadline on time. But
I know it can only take so much of me. So
you've mentioned Renesas a few times, and some of their competitors are having to deal with some news that came out not too long ago from ARM. ARM has been the supplier for the Renesases, the STs, the NXPs for decades. All of a sudden, ARM will be a silicon provider and will be a competitor to these other big silicon providers. What does that mean to somebody like a Renesas?
I'm not too worried about it.
Well, you don't have to worry, but what if you're Renesas?
I mean, I think certainly if they can make some general purpose devices cheaply, and they have a deep understanding of the core, they might be able to give some good support. But when I talk about MCUs all the time, I talk about electronics, I always say, look, MCUs, MPUs, to some extent, and programmable logic are the only devices in our industry where the intellectual property goes into the device instead of around it. What do I mean by that? If you have an op amp in a circuit and you look just at the two inputs and the output, those look exactly the same, whether it's a filter, whether it's an amplifier, whether it's a level shifter, because the device always does exactly the same thing at its pins. And you put your intellectual property on the circuit board around the device to realize the solution that you're looking for. With things that are programmable and the programming goes inside, you are putting that solution inside the device, and the pins functions can change dramatically based on the firmware that you put in. And so you're not just picking a core or picking a clock speed or picking an amount of memory. You are picking, if you pick the right part, you're picking a complement of peripherals that will help you do your job small, inexpensive, and fast, right? So the key to good MCU design especially is the design of the peripherals, not the design of the core. Look at ST, look at Microchip, look at Renesas. They all built businesses without ARM, well before ARM came out, right? And even Renesas has RX and RL, two very good performing on power or on compute. I would say that the V3 RX core, transistor for transistor, outperforms the same device in ARM. It doesn't have the ecosystem globally that ARM has around it because of the ubiquitousness of ARM. Okay, fine. It's about the peripherals. How good is your A to D? how how flexible are your timers? How long are your timers for doing, long-term delay? What does your interrupt chain look like? How good are your D to A's? Do you have comparators on the chip? People poo-poo the analog side, but MCUs are mixed mode devices, 100%. I remember when I was at Renesas and we were looking at a silicon on insulator process. Everybody else in the industry who was playing with this was trying to maximize clock speed. They wanted to make the fastest device possible for the lowest power. Renesas said, you know what? I'm not worried about that because I've got analog on here. I want the lowest noise analog. So when I wake up and I take a piece of data and I go back to sleep, I know that data is good. I have worked with so many 12 and 14-bit A to Ds on somebody's part, and maybe you're getting 10 bits out of it, right? You look at a good A to D peripheral, and if it's 12 bits and you can get 12 bits out of it, if your process is good, if you understand analog design. And I'm not saying that ARM can't hire analog engineers, but hell, these people who have been supplying these mini cities on a chip have been building these building blocks for decades. And they know where all the bones are buried, and they know how to get really good performance on peripherals. Are they going to be a strong player? Of course they're going to be a strong player because of who they are. But for my money, I would use a Renesas peripheral every time. They have really worked hard on making sure that their peripherals are top notch, both in power consumption and performance, and even physical size on the die, which means lower cost. So I think they'll be a strong player. I don't think good silicon companies who have really good peripherals and a strong ecosystem already have to worry that much. The ecosystem is going to be the big thing. There is such an ecosystem around ARM in general now that if they start building the ecosystem around the devices, that's going to be the thing that's going to push people, especially the mass market, because they are looking for solutions at midnight. So they're looking for community support. They're looking for really good documentation. They are, and so that's going to be the play.
Yeah. The other thing I see there, loyalty for an engineer is huge. Getting an engineer to switch from one vendor to another, you have to, it just doesn't happen. We've been doing these studies for years and years and years. Which architecture do you use, and what would it take to get you to switch? And they just don't want to switch.
Yeah, I mean, some of it is loyalty to the company. Some of it is loyalty to the local supplier. Although there's less of that now. When you and I were young engineers, you'd have small distributors everywhere. They would come in. They'd spend time with you. And now it's like
it's fear. It's fear.
Well,
this works.
It's fear.
This thing works, and I know it works. That one might be 4% better, but I'm not taking a chance that that's the way that I see it.
Yeah, I mean, I do a lot of marketing consulting around technology, and I always hesitate when someone says, "Well, my competition is doing this. We have to close the gap with the competition, or we have to be more like them." You should know what your competition is doing. I'm not saying ignore your competition. That would be a silly thing to say. But you are not measured against your competitor. You are measured against your customer's needs. So if you understand what your customer needs and you close that gap, by definition, you'll be closing the gap with your competitors. Because if you get to be as good as your competitors and you spend that money, there's still no incentive to switch. You need to be better. And what does better mean? It means that you're solving your customers' problems better. So being more intimate with your customers' needs and moving in that direction will automatically differentiate you from the competitors and help switch. The statistics on people switching is amazingly, it's like 6 or 7% or some ridiculous number. I mean, it's just crazy. You've got to really demonstrate a difference.
And it's only because a bean counter found something cheaper.
Well, that's how ARM, ARM did a bunch of smart things. One of them was their university program where they really got kids in school to get familiar with that architecture. And there were so many different architectures that when they came out of school and needed to pick apart, they picked the one that they knew from school, right? So that was a really, and I got that word right from somebody at ARM that I happened to meet on a plane, and we were talking about it. But the other thing, besides the ecosystem around it, is getting the purchasing people to believe that you can replace any ARM part with any ARM part. And they thought they could pit Renesas against Infineon against ST because it wouldn't matter what the socket looked like, right? And of course, engineers know that that's not possible. It's possible, but not probable. And you saw that during the pandemic where people couldn't get parts and they tried to move to somebody else's ARM part, and it was tons and tons and tons of code work, right? To make that happen. So I think that was the promise that made engineering managers say we're going ARM, and helped to kill a lot of the proprietary architectures. So those were the three things: the ecosystem, the promise, the false promise of being vendor independent, right? Vendor agnostic, and the ecosystem around the part. So
very good, Vincent. Always good to chat with you.
Yeah, it's great to chat with you.
I love your perspective. I don't really care for your tie, but I do love your perspective.
You know, we should take a picture of this and post it on the website and get people to vote. Two fancies and a plain. I have a very plain jacket that I have over this, just so you know.
I think that is a non-truth because you have nothing that's plain.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.